Hello, everyone. Welcome back to Unwinding the Spool podcast. My name is Andrew, and I'm joined by one of my best friends, Will. And we are two guys that absolutely love 3D printing, and we thought we'd do a podcast to talk all about it and share some cool stuff with anybody who's looking to learn more, that's just getting started, or has already been doing it a lot and is just trying to enhance and make their skill set even broader with 3D printing. So we just started our second season for the podcast. Our last episode 0, as we called it, was just kind of a reintroduction, what we've been up to, related to 3D printing and also not related to 3D printing, just in kind of our general personal and professional lives, and kind of our general plan for the podcast moving forward, including topics that we will want to cover. So, Will, you want to just kind of say hi before we get going?
Yeah, sure. Just want to thank everyone again for supporting us along the way here. We've gotten some fantastic outreach from people about, liking the podcast, enjoying how we talk about it and bringing our different experiences. I think it's an interesting season. It's going to be great. We're going to talk a little bit more about maybe some specific things within the world of 3D printing that, such as materials. We'll talk about materials. We'll talk about how to, design for 3D printing, all kinds of things like that. So just be on the lookout for that this season. And today we're actually going to dive into the topic of hardest projects. So this is from both of our personal experiences, what our hardest 3D printing projects have been so far in our lives, and then a little bit about our own senior design project that we both worked on that was rather difficult. And then we're going to also have a segment today of 3D printing in the news, and then a print of the podcast segment as well. So just to jump right into it, Andrew, you want to talk about what and when was your hardest 3D printing project?
Definitely. Yeah, no. So I've kind of got two in mind. I'll focus on definitely, which is my hardest project, which came from my previous professional job. And then I'll kind of lightly talk about one that I did at home using my own personal printers. So by far, my most difficult project, I'm working on some, and for those that didn't listen to the previous episode, I recently switched jobs in August of this year, and I joined a dedicated additive manufacturing team for a rather large aerospace company here in San Diego. We make some very awesome aircraft, and I'm really excited to be a part of the team. But at my previous job as an industrial/mechanical engineer, the entire site was focused on what was called MRO, maintenance, repair, and overhaul. They were not a OEM, original equipment manufacturer, so we weren't building new aircraft, but we were focused on repairing and restoring and extending the life of existing aircraft in service that are coming in for major or minor services of all different sorts. I was assigned to this one aircraft platform, and there were a set of bearings and pulleys that were part of the main rotor drive that drove the main rotor and the tail rotor for the helicopter that it was on. And these bearings and pulleys had a shelf life of a certain period of time. And basically, to extend that shelf life, the bearings had to be spun at a specific RPM for a specific amount of time, to basically avoid having to perform a very costly overhaul and rebuild of the entire bearing and pulley assembly. So these pulleys, which were all mounted in a very specific bracket and very uniquely shaped, there's nothing else like that. It was tailor-made specifically for this aircraft. So there was no supporting equipment to test these things. And that was one thing in the MRO world we found out a lot was, there's a lot of support for the aircraft when it's new, but as it ages and things break or have to be repaired and restored, there's not a lot of support. So that enabled a great opportunity to 3D print design and then 3D print an entire fixture with a DC motor, a V-belt drive system with idler pulleys and tensioner pulleys, and then a special modular mounting bracket that could mount in there were a few different shapes and sizes of these pulleys that had to be tested. So we could 3D print one type of bracket of a certain shape and then 3D print another type of bracket at a different shape. and mount that all into the same fixture so it's as cost effective as possible. We have the motor controller, we'd spin them up, we'd check for leaks and everything. And that was that fixture, and it saved a lot of money when it came to having to overhaul them and now just extending the shelf life. So I'd say the biggest challenge with that project was reverse engineering a lot of the parts because a lot of the drawings weren't available. So, having to kind of do a lot of precision measurements to get fitment right. And then the other challenge was being able to specifically design this fixture with available off-the-shelf materials in mind. So I had to make sure that, if I wanted to make this bracket this big, there was a bolt size or a nut or a fastener that could mount into that to make up for all that. And so that was a challenge. And then on top of that, I'd say the other biggest challenge was just tolerancing and learning about, just tolerance stack up, right? And so, when you 3D print something, you have a tolerance depending on the precision of the 3D printer you were using. And we were using a combination of like desktop Ultimakers and industrial Stratasys printers. So we're working with different printers here. And so tolerance stack.
It's a crazy spectrum to have to tolerance stack on, though. Like this, hey, this is a system you might find in elementary school, and then this is the system that you wouldn't find anywhere outside of here.
Right. Exactly. So,
oh my God.
Yeah. So there's definitely a challenge with tolerance stack ups and learning that. And then, I never took a vibrations class in college, but man, did I learn a lot about vibrations and like resonant frequencies because when you would you would turn the motor on and spin the belt to then spin the pulley and you get the idler pulley spinning and vibrating, you'd have things like vibrating loose. It was crazy. And the other thing that I didn't have like I helped design and 3D print the parts and the enclosure for this, but we also, I had a coworker that I worked with that he was really savvy with like Arduinos and electronics. And so he used, so we needed to verify that the RPM from the motor controller was actually what it was spinning at so that we could assure that the pulleys were being tested at the right RPM. And so he developed this special little Arduino with a screen and using 2 Hall sensors and a magnetic kind of wheel. And he did a calculation based on the diameter and everything. And so we 3D printed a bunch of enclosures and all the little brackets to hold the Hall sensors on. And we were able to do a readout of the speed of the motor.
So you could get real-time RPM, like actually what was transferring from your control to the pulleys themselves.
Yep.
That's so. Did you guys do any 3D scanning for that project at all?
No, that was a lot of the reverse engineering. I say reverse engineering. I mean, it was doing hand measurements, and actually, one of the tools and kind of tricks that I used throughout that project was, I believe that the official term is photogrammetry, where you take you try and take a picture of an object as normal to it as possible. So imagine like you have your phone pointed straight down to like your desk.
Oh, yeah.
Yeah. And so you then at the same time, you put a ruler or some type of device or piece that has a measurable, tick system or tack system on it. So then you can scale the image appropriately and you can actually throw that into SolidWorks and trace the image.
Yeah.
So that was, at this job, it was always about balancing how many hours were allocated to the project, like labor hours to, what was required. And so 3D scanning and completely doing a whole in-depth reverse engineering with like a crazy handheld point cloud scanner would have blown the labor hours way out of proportion. So we had to keep it pretty kind of, I don't want to say rudimentary, but there was a lot. How I kind of got around that was I had the model and then I would take sections of the 3D model and instead of printing the whole part, I would just print like a little slice of it so that I could see how it fit. So there was a lot of fit checks throughout the process. So that was a, rather long-winded explanation, just kind of say like, tolerance stack up, building something so that it can work with off the shelf, readily available components, and then just reverse engineering something and like learning about vibrations. And there were a lot of things we learned that, like this needs to be mounted this way because the vibrations are going to cause us to walk off of this drive shaft or something.
Wow.
So, you can do all the CAD you want, but sometimes for like a really complex system, you just kind of gotta get it, hands on with it to understand. So that was kind of my most challenging project at my previous job. I'm working on some really cool and really challenging projects at my new job, but I don't want to kind of dive into too many details with that. But it's the project I'm working on now at my new job is also related to reverse engineering something so that when you do a comparison and you basically lay one model over the other versus like the non 3D printed part versus the 3D printed part, you want to make sure that the deviation between the two is next to nothing or within the acceptable tolerance. And then just designing with tolerance stack up in mind with the part itself, like hardware that you have to mate to, brackets that you have to mate to, and the tolerances of the printer. So that's a cool project I'm working on right now at my new job. It's definitely challenging me a lot. And I'd say on a personal project level, my most challenging project wasn't really so much related to design. It was related to how large the part that I was trying to print was. So I don't have a picture, but because we are so focused on audio version of this podcast, I'm going to do my best to describe it with verbally here.
Paint a picture, Andrew. Paint a picture.
Yeah, paint a picture with words here. So my father-in-law has a 14-foot aluminum fishing boat that we take up to Mammoth every year to go fishing. And on the front of the fishing boat, where there's this kind of ratcheting strap that you use to pull the bow of the boat up to the tip of the trailer when you're not launch, you're capturing the boat again, I guess, after you're done.
Docking it
on the trailer. So when you're doing that, you kind of have to take your weight off of the boat so that it doesn't push it down and it can't get in the right spot. So he wanted to have this kind of step so that you could step on the step of this part, take your weight off the boat, and then, fully crank down and secure the ratchet strap for the trailer. So he was thinking about making it out of wood, and I was like, no. I got 3D printers. We're going to 3D print this. So
we have the technology.
So I guess it was a little bit of a design challenge because, given any person, how heavy they weigh, you don't want this step snapping when they're stepping on it. So I had to design this thing so that it was robust and beefy enough so that it could take a person's weight. But the biggest challenge with that was, given how big it was, I pretty much used almost an entire spool of filament for this entire part. So it stunk because I had a few part failures. So basically I have to start from a fresh spool every time or else it wouldn't be enough. So I burned through a lot of material, and I had a lot of issues with under extrusion and getting nozzles clogged a lot with PETG, just something with I think as it got up through about halfway through the part, after it had done so many, thousands of retractions for the print path, it just started to get like a nozzle clog, and then you get like a spongy, non-structural print. So I ended up going with a tough PLA, and it's held up really well, believe it or not, because it's not getting crazy hot or anything. So we'll see how well it holds up to the elements, because I know PLA can always be questionable with UV, although I have had a PLA part sitting on my side yard fence for over a year now, and it's still as good as the day I put it out there. So don't really know. But that was my most challenging personal print, I'd say.
Nice.
So enough about my challenges. Will, why don't you dive into your challenging projects?
Sure. We're going to talk about with the senior design project. We'll talk about the a little bit of the stuff that I experienced with that. So I'll keep mine to a personal one, which is I as a side gig sometimes would take on design build little projects. Mm-hmm. And one of the most challenging parts of that, I would say, is dealing with a customer, dealing with a client. I think that it's easy when it was things for myself or things for a friend, because I could be like, hey, dog, like, I don't, or like, look, I can't, you want it this way, but that's not how 3D printing works. And they would be like, cool, you're the 3D printing guy. I'm just going to take your word for it and accept the fact that this has to change. But when I was dealing with this client, it seemed like a really easy project at first. This is the thing. It seemed so simple. They wanted to make a bucket that they could fill with like sand or water. And I was like, easy. You have specific dimensions. I made a scale model. The scale model was great. Like the CADing was so easy, so simple to make it what they wanted. So the designs, I sent off the renderings. They're like, great, print a scale model. Printed a 1/3 scale model, sent it off to them. They're like, great, we want you to make it full scale. And I was like, well, okay, so, because the object had to be, God, if I recall this, it had to be like 24 inches tall. And I was like, that's a big print volume for one thing. And so at first I was like, guys, I don't, we should probably get somebody else to make this in a different way. Yeah. Like, probably not 3D printing. I'm trying to convince them. And they're like, well, what would it take? What would it take? And I was doing this thing where I kept trying to throw out things that would be prohibitive in cost, where I'd be like, well, I would need you to help me buy another, a new $800 machine. And I would need you to help me, it would cost this much in material. And they're like, fine, we'll write a check. I was like, well, okay. I mean, if you're going to buy it, I guess I'll try. And so I tried, and get this, it didn't work. Just printing at that scale, all of the things, like everything that can go wrong on a small scale and be kind of corrected with post-processing, all of a sudden goes wrong at a much larger scale. Mm-hmm. And now all of the things like not having a very solid top layer because all the other layers are having to span across a very long distance. It was 8 inches in diameter. It was big. And it had to have like a hole in the imprinted lid, which meant that hole was like getting printed in midair of nothing. And so I was like, guys, this isn't going to work. And then I had to buy, I just remember that's like very few projects I've ever ended with I can't be done. Like, what you want cannot be done. And I mean, it easily could have, but the problem is what they again, going back to the customer service side of this, and I'll take some of the blame. I definitely kind of thought in my own bravado that I could well, if you give me enough money, I can do anything. Sure. Which was definitely as a person with a full-time job and no workshop, I was just like, no, okay, I shouldn't have done that. I didn't have the tools to do it. I just was like, yeah, look. And I hoped that when I said, look, you give me enough money, I'll do anything, I was hoping that enough money was way too out of their budget. So I didn't anticipate anyone saying yes to that. And then the other thing was, I think, and this has occurred to me on a couple of projects, even back at the UC Irvine days where we were doing projects for other departments or other groups, where they wouldn't really understand. They thought 3D printing, and people still do, they think it's this magical thing, right? They give you an idea, you make them a design, and then magically that becomes this solid, beautiful object like it's Star Trek. And that's just no matter how many meetings I have with these people, they were always like, why doesn't this look like a more finished product? What are all these lines? And I was like, well, that's how 3D, I would send them videos of it going. I was like, this is how 3D printing does things. You're gonna have lines, especially if you want it printed like this on this kind of machine. So there was lots of things. And then every time I would try to do a design workaround, they would go, no, we want it done the way you gave us the scaled model. And I was like, well, that's a scaled model. Yeah. And scaling up directly within the same system actually doesn't work the way you think it works.
Right. Yeah, it almost requires a complete redesign. And I mean, still capturing the overall same design, but there's a lot of then features you might have to add in so that it prints well.
Right. And I kept trying to be like, look, you can just have the CAD designs, take it to somebody else. I suggested shops, people down near them. I was like, and they were just like, no, we think it's easier for you to do. I'm like, I'm telling you, it's not easier to do if I do it. And then the flip side of that, the hardest project that went well, I think, is this design I made for someone. I don't know how much I'm allowed to talk about, But basically, the idea of it was something that would help pick up trash while you're out hiking. And I was working with someone who's really good with clay modeling. So that was a very interesting challenge because I was getting objects molded out of clay and then having to 3D model that, which without a scanner, like I don't have scanning technology. I don't do that. Similar to your problem. It's like the amount of hours and time to go do 3D scanning was prohibitive. So I was like, okay, same idea. I'm going to do, try to take a photo to reduce parallax and have have some measurements stick in there and I can, get some rough idea. But that was a really cool challenge because I got way more finesse in my own modeling abilities because I'm a pretty, when I make functional prints, I don't make them look pretty. I'm just like, all right, box, hole, done. Cool. It works. But this was a lot of it had to have this look and it had to have certain finesse and curves and things like that. And these curves had to interact in certain ways. So that was a good challenge with a client where I really felt like I got to actually learn a lot about how I wanted to model things. But also that one succeeded in actually creating a finished product, unlike the other one, which was just such a simple thing where the design took me maybe, a couple of hours, but the just back and forth and constantly having to try. And then similar to your problem, Andrew, which is that each try took a spool of filament. So, I'm buying material out the wazoo and just blowing through it. And I'm like, okay, that was the 5 tries I got with that stuff. And now I got to wait, get another 5 spools.
Yep.
So,
yeah.
No, that was my experience.
Yeah, that brings up, don't mind me, I'm trying to figure out, my computer for some reason isn't charging. So I'm just trying to diagnose this on the fly here. But your challenge there with the customer kind of not understanding the technology is definitely an interesting challenge in any industry that's related to 3D printing. Is you have to, because it's such a relatively newer technology. I mean, say within the 21st century, it's still pretty new and the applications are growing. It's trying to convince that the customer, whether it's we say customer where I work is that's the same. It's just a different department. So you're designing something for a different department. They're still a customer. Or if they're an external person, they have no idea of 3D printing. So trying to convince and convey that information to them can be a challenge. And the limitations and hey, really, you got to print it this way or else it's not going to turn out well. Or you got to use a ton of support material, things like that.
Absolutely. And it also sometimes feels like you're you don't want to be the curmudgeon. You don't want to be the person that's no, go away. We can't do that for you. You do. There's the poetic part of me that wants to be absolutely, we can do whatever you want. It is a miracle technology because you and I are part of this maker space movement where you want to be positive about it because you want more people to use it. But then there's also that part of you where you're like, oh, that's going to be a really hard project. I don't know if I want to do that. that seems like a good idea for somebody else.
Right. Yeah. I completely agree with you. I'm all for being, trying to challenge yourself. And I never like poo-pooing 3D printing. I want to say, yeah, let's try it. As long as it's not going to put anybody in danger. Right?
Yeah. Absolutely.
Whether for various reasons, let's try it and see what happens. And we can learn from our failures if it doesn't work out well. And sometimes where I'm at is hey, let's try it 3D printing with FDM. Does it not work well with FDM? All right, well then let's maybe try, powder bed fusion instead, and that maybe would bode better to the geometries that you have to print. So yeah, so I always kind of my kind of coin for it is responsibly ambitious,
There you go. Ooh, I like that. Ooh.
Push the envelope so that the technology grows, your skills grow as a designer, engineer, etc. But at the same time, you don't want to be biting off more than you can chew because then that could put a bad look on you and a bad look on the technology too. You want to keep it a positive mindset in people's, scope so that they don't disregard it in the future.
Yeah, I could definitely that was one of the customer that wanted the bucket thing. Like, I definitely made them think 3D printing is a dumb thing that should never be used. And I'm like, oh, well, that, whoops. So I was like, whoops. But then, you have customers like this one guy that wanted the trash collection thing. And he was like, this is awesome. I can't believe that I get to look at something that feels almost like a final product. Right. Made out of something that's actually, he's used to making things in clay and hardening them in a kiln, and it takes a long time, and you can't mass produce things like that, at least the way he wanted to. And so it was, I love that. I love that. Responsibly ambitious. Like, you gotta have that, run that line.
Yeah, because you want to push the technology, you want to grow your skills, but you don't want to make a fool of yourself at the same time.
No, you don't. You don't want to make a fool of yourself. Trust me.
And maybe you just put a disclaimer out there to your customer, whoever, and say, "Hey, this is definitely pushing the limits for what I've done, what my printers have done. It might fail." And if you give your customer that heads up of ahead of time, then you know what? I don't see anything wrong with that, as long as they're aware of the time cost that might be involved with a possible failure, something like that.
Yeah. So. Yeah, exactly. And I think that's always a good way to do it. I mean, even sometimes though, as a thing to say is like when you do that, sometimes people, maybe they've seen one too many movies and they have the happy ending. They're like, yeah, no, I know the risks, but let's do it. And then you fail and you're like, well, you said you knew the risks, and they're still mad. But that's just on that point.
Right. Yeah. So yeah, we've definitely, through our, 8 years of doing 3D printing you longer than me, but, we've definitely run into some challenging projects here.
Oh, yeah.
I think I got started in 2016, and you probably, 2014?
2015, so with a Decathlon, yeah. 2015.
Okay. Yeah. So,
yeah,
it's been a while now, but yeah, I'm excited for pushing the limits too. Little tidbit, I just got another printer. So the new printer is going to be strictly for tinkering and modifying to challenge myself and new materials. So
beautiful.
So it's going to be a future podcast topic. But let's jump into, so for those that don't know, Will and I really had a great time, and this is really where I cut my teeth on 3D printing, was our senior design project when we both were studying engineering at UC Irvine. So, Will, do you want to kind of give a quick backstory of kind of our project? It doesn't have to be anything crazy, but just kind of a general synopsis.
No, yeah, absolutely. A quick thing just to kind of summarize it in a, like an elevator pitch style, which is, when I got started in 3D printing, we posited the idea that you could recycle materials from around your house, around the community, or just your own 3D printing waste back into material you could use on your 3D printer. And we thought we'd seen some things that were, advertised as solving this problem. And so back in 2015, when this project started, we were like, cool, this is going to get like a small grant from the school, buy some equipment. It'll take us 6 months, and we'll prove it. Okay, cut to when Andrew joins the project 2 years later, and we have still not solved it. And we are now having to. We've started solving it, but there's a lot of research has gone into it, kind of culminating in this project that we did for our senior design showcase, our engineering school's showcase, which was the whole project was a cart, like imagine like an AV cart that had both a system that could grind plastic, a system that could melt that plastic back down into a filament, a very accurate filament, and turn that, that filament would then go onto a 3D printer and you would print it. Also, as a fun, another fun part, the whole cart was powered by a solar panel and bikes. So we powered the whole thing by solar and bike power. And so that was kind of was this sustainable kind of loop of both, sustainable energy meets nutrient recycling, all in one space. That was the sum of it.
Yeah, it was definitely a fun project, and it was as much of it was like a great culmination of a bunch of different engineering fields. So you had like mechanical engineering on designing a lot of the components for the cart itself. You had electrical engineering for doing a lot of the circuitry and the sensing system and everything. We had environmental engineering to kind of understand the environmental implications, electrical engineering to understand the electrical demand of the cart and everything, and material science. So it was.
And on top of that, we had computer engineering too. We had computer science and engineering in there as well to design control systems.
Yeah, so it was a great project, and I'm very thankful for all the opportunities that we had for that. And but thinking back to some of the challenges, I mean, I know you started on it before I did, Will, but like I'll just start off because I was focused mostly on the grinder system. Was my
you got to talk about that, yeah, please.
So, one of the biggest challenges, right, when you're trying to recycle waste plastic is getting it down into a flake or a pellet form that can easily be extruded again. Because we were using Philobot was the company.
Philobot. Philobot systems, and they were meant to take pieces that were very small. Yeah.
So the Philobot system, it was kind of like a desktop scale, set of systems that you could extrude and spool your own filament again. Right. And so it had this lead screw with a hot end, and you could, put a different nozzle size. So you get either, 2.85, 1.75 millimeter filament for your printer. Well, the challenge is that we found is if the plastic that you grind from what you're recycling wasn't fine enough, you'll basically get chunks of unmelted plastic in the filament. And that is a nightmare situation for a nozzle clog on your printer. So I think that what that kind of led us to was like, we need to get a more consistent grind is kind of what we called it. Think of like kind of grinding coffee, right? So like if you're doing a French press, your coffee grind is going to be different than if you're doing espresso,
Good comparison. Yeah, absolutely. Yes.
Yeah. I love that. So we had to really kind of tune this grind a little bit. And because the cart was completely self-sufficient, like off grid, so to speak, using a electromechanical grinder was not really an option because of how much electrical draw that would take. I mean, they were talking tons of amps, a lot of voltage to run a motor that, when you get a lot of resistance from grinding it. So we ended up with basically a grinder system. It was a 2-part grinder system. So you get your first kind of like coarse grind. You take the grindings from that and then put it in the grinder system behind it on the other side of the cart. And that would be your fine grind or your final grind that would basically dump right into the extruder. And we had these, they were probably like 3-foot long metal bars.
Oh, God, I forgot the metal bars.
Yeah, and we had these 3-foot long metal bars, like 2 handles. And you basically had to it was an exercise. I remember when we would get, a good arm workout trying to grind this plastic down and get it to just grind well. And then we had to by hand. And we had to design basically a filter system that would keep the grind in the little reservoir and keep it grinding and grinding and grinding until it got to a certain size, and then it would drop through the filter. We 3D printed the filter. We 3D printed the parts of the handles with like TPU, so it was a little bit more ergonomic to grip. So there were a lot of challenges there, and then that kind of led into also some challenges with material science of like how well a certain plastic melts. Like we had a lot of great success with polystyrene, like red Solo cups, but PET, we learned the hard way that PETE is not the same as PETG. So.
Oh God, did we learn that hard?
But hard. That was kind of my fond memory of challenges with that project. How about you?
I had a lot of good fond memories. I love your like the creating of the Stiv was definitely. I remember you coming on the project and I being like, this is something Andrew has to tackle, because like we were all like, there was just so much. There were so many things that had already like had to be overcome. But there was like people very focused on the post grinding of it, and like we were all pretty stumped. We were like, this part, not sure. And then you came up with the idea of printing it, because we were printing it in PLA for the fitments and then trying it out. And of course it would shred apart because you're grinding PLA through PLA. And so the hardness of both plastics was just canceling out. And then you were like, well, let's print it in polycarbonate. So we got polycarbonate, and then we finally had a sieve that could go through it. And we were we really wanted a custom one of metal. Did we ever get the metal one? I can't remember if we ever made a metal one.
We did. I think it was called Filamaker. It was another, like, basically a guy running at the time what would have been an Etsy store selling these little. Let me see if I can find the name of it. I do remember they were metal teeth that there were.
The teeth were metal, but did we ever get that machine shop, the guys in the machine shop at the engineering tower, to make a metal sieve, or did we always print that sieve?
We always printed the sieve.
I guess we did. We always printed it.
And the other challenge with the sieve, and that you just kind of jogged my memory, is there would be so much pressure from the plastic being kind of like pushed down and then trying to be like brought back up through the grind wheels that would actually just blow the sieve out from the bottom. And that was why we had to switch to a stronger material like polycarbonate, because I think we tried PLA, then we went to ABS, and like those were just cracking.
No, it was just shattering on its way through.
Yeah.
The big challenge that I remember trying to overcome, that I really worked on, the biggest one that I remember really focusing on was mine was always sourcing. I seem to always remember working on sourcing material, and finding places to get our material. And so one of the biggest challenges I encountered was we identified, single-use drink cups, like your classic red Solo cup is a great way to get it. But I would go to our local waste handling admin people on campus, and they'd be like, well, we don't sort it. We send it to these guys over at Waste Management. And so I would be like, okay, I guess I'll get on the horn with the guys at Waste Management. Can I get a bag of this stuff? And they're like, we don't actually sort that out. That gets sold on to these people. And that also helped start the company partially because of just my frustration with this like constant, no, they've got it. No, they've got it. It's actually in the port in Houston. Well, the Houston port actually already sold it to Indonesia. Sorry. It's gone. So that was my huge frustration. And then on the technical side of it, I was also definitely the guy trying to desperately get this old Lulzbot Taz 3 or something, this ancient machine to run experimental plastics through it, and then also run outside, because we would demo it outside, right? Yeah. And it didn't have an enclosure, and we weren't going to, I forget why, but it's just like we couldn't get one to fit on this cart. We couldn't get an enclosure to fit. So we were just constantly...
grinder handles.
Because the grinder handle, right. Yeah. We couldn't put a door on it. It wouldn't have fit. And so we were like, okay, well, I guess we're just going to leave it, hope that we can get it to print. And there were definitely some demo days where we kind of had to fake it and put like a half-done print on there and be like, oh, we paused for a second for the wind.
Yeah.
But we had some days where it worked, and I loved those days.
Yeah, I mean... You talking to anybody trying to 3D print. I mean, 3D printing in an open air printer is already a challenge. Trying to 3D print outside in an open air printer is a recipe for disaster.
I remember because I'd feel the breeze on my neck, and I would see the thermostat on the display screen just start tanking. And I was like, well, there it is. That's the clog. And then it would click. And then you start hearing it click more. And you're like, yep, there we go. And
you know what? The other fun thing was our project was interactive. Like we would, as we were grinding filament, we'd have people like, "Hey, you want to come grind some plastic?" And
people would come and check it out.
Yeah, and that it was kind of a cool way to convey because whether you're putting it in as like a metabolic energy, I don't know if that's the right way to describe it.
That is the right way to say metabolic energy.
Electromechanical energy, that's how much force is required to put back into that material to get it back into a melted state, So it's kind of a cool way.
I mean, I really think we showed very well the idea that, like, this is what, these things take a lot of energy.
Yeah.
And kind of as a cool piece, we had like a bunch of school tours. The kids loved the grinding. The kids always loved the giant, because when we had those custom like cool TPU see-through handles, and the kids would love to just grind it. They always said that they thought it looked like a plane or something. I remember the kids always wanted to turn it into a plane. Yeah, they loved it. It was super cool. And then we had these great we had these fixie bikes that we bought, those black fixie bikes, so that we had this cool aesthetic to the whole bike power thing. So it was like, oh, wow, let me power this thing up.
Pretty sure I almost severely injured myself on one of those fixie bikes because they don't, the pedals don't have that neutral gear.
No, they weren't right, because we had them on the fixed version, because we had Tucker with some guys who loved to use them as fixie bikes when they weren't being used, and so they would throw them on the fixie setting.
That was like our lab, kind of like little vehicles. Like we'd ride the bikes to and from class sometimes.
No, yeah. If you were halfway, because you'd be in the art school, we'd be in the art school on the other side of campus, and we're like, oh, we got to get to class. Yeah. So we'd take the bikes and we'd book it all the way to the other side of campus.
Yeah, and it was a fun project. I mean, I really had a good time on that, and got long hours in that lab. But dude, I remember that night that we got the first benchy to print with the recycled polystyrene. We were all like jumping for joy. It was cool.
I like that a lot of people were in the lab at that time too. There's that photo of us with the benchy where we were like, we all stayed up because we were like, we need this. Come on. We're so like the showcase is like 2 days from now. We're so close.
Yep.
Oh god, that was close.
Yeah. So moral of the story is, ladies and gentlemen, listening or watching this podcast, is if you do 3D printing long enough, you will run into some challenges.
Absolutely.
It's inevitable, whether it's a equipment, printer challenge, material challenge, application challenge, customer challenge. It's all about overcoming those and being creative and problem solving. So it's a fun learning experience, and you never stop learning. I'm very much a big proponent of the minute you think you know it all is the minute you're doomed, because you need to always keep learning, no matter how long you've been doing it. So that's Will and I's hardest projects that we worked on kind of on our own, and then also the big senior design project we worked on together. And so this kind of spurred a kind of a thought I had, Will, is like, what about, future podcast episode or season? We kind of like, I know it's tough because we're geographically located at opposite ends of California, but what if we collaborated on like some type of cool project to build something?
Oh, that would be so cool. I'd love to have us have these have the podcast be almost like an update meeting for the people on like how that project's going.
Yeah, that could be a segment of the podcast. So
yeah, that'd be really cool, actually. So we'll find something. There's something to be built. There's always something we can build.
Right. Yeah, we'll brainstorm offline, and we'll let you guys know kind of what we think of and how we can accomplish that. But so let's jump into Will, why don't you talk about first the print of the podcast? So we're going to start some sub-segments within the podcast, and print of the podcast is going to be one of them. And that's just going to be a cool object that we either just recently printed or printed sometime in the past that we want to share with you guys because it was fun, challenging, unique, etc.
Yeah, absolutely. So print of the podcast, this is going to be a little harder for those of you that are listening in, which is the vast majority of our audience, but I will describe it. It's like a Christmas tree topper. It kind of looks like if you combined an icicle with an ornament and then kind of made it look like these curves that curl almost like a candy cane. So if you combined a candy cane, an icicle, and an ornament together, that's kind of what you got. And the reason that I love doing this print was I love vase mode prints. So for those of you that don't know, vase mode is where you basically print an object entirely with like one layer of thickness around the outside, and it's continuous. So it doesn't hop up to the next layer. It just kind of continues it up and up and up each layer, like you're going up around the stairs of a lighthouse almost. Is kind of the best way I can describe it. So I love vase mode prints. They're incredibly impressive. They're also they're deceptively easier on your printer because there's that continuous motion and continuous tension on all of the axes. You actually are able to get a smoother print, even though it looks a lot more difficult. Don't get me wrong, if your printer is completely messed up in terms of your tuning, you're going to have a hard time printing anything, including vase mode prints. But I love these prints for that reason. The other thing I did was Prusa Slicer recently came out, not recently, but they've had for a while this thing called the fuzzy finish setting, where it kind of forces the printer nozzle to be vibrating at all times. And so what that does is it, instead of having a nice smooth finish, it creates almost what looks like a felt finish. It gives it a lot of texture. And so on this one with this color, it's not as good as I'd hoped. It looks great. But I can imagine doing it with things that like maybe something you would want it to look almost not 3D printed. This actually helps a lot with the making it look like a solid object rather than an object that has a bunch of layers to it.
Got it. So it hides the layer lines when you do that fuzzy mode?
Absolutely, yeah. So, I mean, like, if you know what 3D printed objects look like, you can see where the layers are. But if you're not, to the layperson, it definitely just looks like, oh, that's just an object. That's just a thing that's made that way.
Cool.
I'll have the model file in the description of the podcast. So if you want to check it out, it's on printables.com. So that's our print of the podcast for today, especially timely considering we're heading into the holiday season.
All right. I bet you that one would look really cool if you made it in like the silky, shiny PLA.
Oh, yeah. I should get some of those.
Lights. Yeah.
Ooh, I should get some of that.
Yeah, I used some silky blue, and it has like almost a metallic sheen to it, so it's pretty cool.
Ooh. But I've been really play around with silky stuff too. So Andrew, you're doing a new segment today as well.
Yeah. So Will and I will probably like switch off on who does what subsegment of the podcast. But today I am introducing the 3D printing in the news segment. So basically, Will and I, whether it's through Google, through being shared from a friend or family or coworker, with a recent development or article of 3D printing in the news, how the technology is emerging, changing, getting better, etc. So because I am a big aviation geek, I work in the aerospace industry, I am just going to start right off with one that was shared to me actually today by a current colleague of mine. So it's from 3D Printing Media Network, and we'll have a link to this in the description as well. But basically, it is an article highlighting how Northrop Grumman, so for those that don't know, Northrop Grumman is a big aerospace company in the United States. They're a big defense contractor. They build a lot of military aircraft. But there is an article posted about them today, or recently, sharing basically how they've been putting a lot of R&D into developing this system, what was called a Scalable Composite Robotic Additive Manufacturing System, or SCRAM, I guess is what they're kind of
I love it.
pointing it to support, emerging aircraft and missile systems, basically. And it's pretty legit. So the picture that you're kind of looking at here is it kind of looks like the robot is building kind of like a vase in
I was about to say, it looks kind of like vase mode stuff.
yeah, and it's pretty cool. The robot, so from what it looks like, it's kind of like a conventional KUKA robot arm that you'd see in a lot of highly automated manufacturing processes like the auto industry. But it's the head on this KUKA robot arm that is really the trick here, and it's laying down all this crazy continuous composite material. So it's a lot of times it's like a tape-like material, or it could be like an extrusion. But a lot of times when I've seen it, it's like a tape, and then there's a roller that follows behind the tape to roll and press it. Sometimes in this case, it's like free form, and some other times it's onto a mold. So they either extrude it, roll it, and then press it. And then a lot of other times there's like a UV light falling behind it to cure like an impregnated like resin of some kind to solidify and cure the material. And I guess the reason why it's called SCRAM or scalable is that you can make this super small, or you can make it really big and basically work to building an entire fuselage or structure of an aircraft. So it can be scaled up rather quickly and easily, I'd say, in a relative sense, with cost in mind in the aerospace industry and what they have to deliver. But it's pretty cool to see this. So it's kind of a continuous fiber composite robot at a larger scale. And so
that's really cool.
Yeah. And so for those that don't know, I mean, the Boeing 787 and the Airbus A350, the two largest kind of latest generation commercial airliners, those fuselages are all composite, and a lot of the wings are composite as well. And if you would have rewound 30 years ago, composites really didn't exist, or were just starting to kind of get into the aerospace industry. And now you have entire planes, a large majority of the materials of the plane being made from, kind of deposited composites.
Right. And so, Andrew, we've talked about this before of having additive manufacturing be a part of aerospace in a big way, but not always be used as like flight ready kind of systems. But I'm looking at this and it's, printing this engine duct, and that looks pretty freaking cool. And it's, like, do you think we're really getting close to a time where we can use additive manufacturing for flight ready systems that are like, maybe even pretty like, how do I put this? They're pretty mission critical systems. Does that make sense?
Yeah, no, it's kind of the term for that in the aerospace industry would be a CSI, or critical safety item. Each company might call it something differently. It's I would say, I don't know the exact percent. I'd love to say I know a lot, all throughout the aerospace industry, but I'd say additive is not quite there yet. And I might be wrong. There might be something that I'm not aware of. But from my experience of my current and previous job is we're definitely getting there for critical safety item related components. But additive is still kind of maturing to the point where, we don't want, if this part were to fail because the materials, we're still kind of learning about the material properties and how they behave in flight and things like that. It's going to be a while, but, I don't know, maybe you might see a 3D printed landing gear component, in sometime in the future. But I'd say because this is like a duct, this itself might, I don't know how this Northrop kind of qualifies this part, but it might be considered maybe a critical item of some kind, because if this were to fracture and a chunk were to break off, I mean, that it's an engine duct, that thought is going, foreign object debris is going straight into the engine. So there's some level of, of safety and reassurance that has to be there with this part. But I'd say probably, to answer your question, not entirely there. And again, I might not be aware of everything. I'm definitely not aware of everything, but we're definitely getting there.
Right. Cool. That's kind of what I wanted to talk about was, like that idea of, though we can maybe see these like tests of them making these parts, especially, whether or not they're actually going into production or, flight ready systems. Like, are they actually going on there? We don't know yet. I mean,
yeah. I know for a fact, from where I work now, and then a bunch of other companies, OEM primes in the aerospace industry, there are additive components flying, like 100%.
Right.
All different kinds. There's high temperature polymers. There's metal components. It's all dependent, again, on where they are installed on the aircraft and what their application and function is. So
gotcha.
I'd say as the technology evolves and we learn more about it and the materials evolve, that's the biggest hold up right now is the material science and the material allowables are still, they've matured a lot. There's still a little bit of a gray area with some of them, but
right.
It's a cool time to be in additive in aerospace because it's growing a lot.
Absolutely. Yeah.
So that's 3D printing in the news. So that was aerospace this week. So we'll probably find another industry for the next podcast, and we'll keep on keeping on with what's the latest in 3D printing.
Yeah, absolutely. Very exciting.
Yeah. So, ladies and gentlemen, I think that's going to wrap up this podcast. We're kind of approaching our hour mark here. So we hope you guys really enjoyed kind of hearing about our challenges that we've had to overcome with 3D printing on a few of our projects, a little tidbit of what we've worked on over the years here. If you have any comments or questions for us, please feel free to shoot us an email at unwindingthespool@gmail.com, and one of us will get back to you, or just leave a comment on the YouTube video, and that works as well. So, Will, do you have any parting thoughts here for the night?
Parting thoughts, just want a quick plug. We talked about problem solving and troubleshooting. There is an episode from season 1 where we talk about how to be a good troubleshooter. So, not to plug our own podcast on our podcast, but feel free to go check out that episode if you want to learn more about how to be a good troubleshooter, especially in 3D printing.
Yeah, definitely one. I'd say the most important skill to have as a maker / 3D printer is being a good troubleshooter.
Absolutely.
So again, yeah, on that note, it's time to go to bed. But yeah, thank you again, everyone, for tuning in, supporting the podcast. We appreciate you all, and we are excited to see how this podcast continues growing as we continue to produce more episodes to entertain you all. So thanks again so much for listening, and other than that, everyone, we will see you guys in the next episode.
See ya.